Let's look at how Linty fits into the verification flow, specifically around simulation and test bench coverage. We start from a standard project setup using continuous integration. Every time code is pushed to GitLab, a CI workflow is automatically triggered. The pipeline retrieves the code, elaborates the design, and runs the test benches using third-party simulators such as ModelSim or QuestaSim. These simulation tools remain external. Linty does not replace them. Once the simulations are complete, Linty is executed as part of the same CI flow. At this stage, Linty performs code quality checks and collects the reports generated by the simulators. Rather than just displaying raw results, Linty interprets and enriches this data to provide actionable insights. Here we can see the global coverage view of the project. Overall, about half of the code base is covered by tests. That gives us a useful high-level picture. But Linty's real value is the ability to focus specifically on new or modified code. Linty introduces the concept of a baseline, which you can define however it makes sense for your team. Changes since the beginning of the month, since the last customer delivery, or since a specific release tag. From that baseline, Linty analyzes only what has changed. In this example, coverage on the new code is only 30%. If the team's goal is to ensure that all the new features are well tested before the next release, this is a clear warning signal. Ideally, we want to get as close as possible to 100% coverage on new or modified code so we can confidently say that the recent changes are validated by automated test benches. From a verification engineer or team lead perspective, the next question is obvious. Why is coverage so low and what needs to be done? With a single click, we can see which files were modified since the baseline and drill down into one of them. Linty visually annotates the source code. Green indicates code covered by test benches. Red indicates uncovered code. And mixed colors show partially covered conditions. On top of that, Linty highlights new or modified code directly from Git history. The sections shown with blue background represent exactly what was added or changed since the baseline. In this example, we can immediately see that while part of the new code is covered, a specific condition that was recently added is not exercised by any test bench. This tells us exactly what we're missing. We need to write a test bench that drives the right input conditions and verifies the corresponding output behavior. That's the core value of Linty. In just a few clicks, a verification engineer can identify uncovered logic, understand whether it's legacy or newly introduced code, and see precisely where to focus effort, turning coverage data into clear, actionable work.